Hi, I am Michael. This is a walkthrough for the sliding down a ski slope on your back physics problem. I don't make physics content. I just couldn't find any helpful resources for this problem online, so I thought I might be able to help somebody out by posting a video on it. Our knowns for this problem are that our initial velocity is negative 12 meters per second. It's negative 12 because we know that our speed is 12 meters per second down the ramp, and that a x-axis extends up the slope, which makes our velocity negative. We know that our coefficient of kinetic friction is 0.25, and that the time that A, B, and C take place in is 7 seconds. This is a simple diagram representing the skier as a square, and this is a free body diagram with respect to this coordinate system. To start this problem, we're going to be starting off with the net force equation. Net force is equal to the mass times the acceleration. And we're first going to do this for the x-axis. So the net force in the x direction is equal to max. We also know that this is equal to Fk minus mg sine theta minus mg sine theta. So if we know that these two are equal to each other, so we know that we can write Fk is equal, or Fk minus mg sine theta is equal to max. We also want to do these sets of equations for the y-axis. So Fy, we know that this is equal to 0. And we also know that this is equal to Fn minus mg cosine theta. And this gives us that Fn is equal to mg cosine theta. Well, we want to solve for the acceleration in the x direction. And to do that, we need to know what Fk is. And we know that we can solve for Fk with mu sub k times the normal force. We know that the normal force is equal to mg cosine theta. So we know that the force of kinetic friction is equal to the coefficient of kinetic friction times mg cosine theta. And we can take this and plug it into our equation up here and get that mu sub k times mg cosine theta minus mg sine theta is equal to m times the acceleration in the x direction. We have an mg on both sides here, so we can pull that out with mg times mu sub k cosine theta minus sine theta is equal to max. We have m on both sides, so we can cancel those out. So we're left with the acceleration in the x direction is equal to mu sub k cosine theta minus sine theta, that quantity multiplied by g. Another physics equation that we're going to need to use is the final velocity is equal to the initial velocity plus at. We know time we know initial velocity and we know A right here. So we can write that our final velocity is equal to our initial velocity plus this equation right here times t. And if we plug in all of those numbers, for A, our theta is 12 degrees. If we plug in all of these numbers, for A, we get negative 9.49 meters per second. For B, theta 18, we get negative 16.89 meters per second. And for C, theta 25, we get negative 25.45 meters per second. Now, part D is a little bit tricky. If you avoid all obstacles, on which slope will you slide to a stop and how far will it take? And this is a little bit tricky because, well, I'll explain the tricky part later. The first part is really simple. On which slope will you slide to a stop? A is the only slope where our velocity decreases, our speed decreases, because our initial velocity is negative 12 meters per second, and our final velocity is negative 9.49 meters per second. Both B and C increase. So we know that it will be the blue slope. And how far will it take? So for this, we can use another physics equation. Final velocity squared is equal to the initial velocity squared plus 2ax. Now this x will give us the displacement. But we can just later take the absolute value of it to get the distance because it wants how far, not what's the final displacement. If we solve for x, since we know that we want our final velocity to be 0 because we're stopped, we get the equation negative the initial squared over 2a is equal to our x displacement. And if we plug in the values, use this acceleration for a, we get that x is equal to negative, 200.6 meters. But since it wants the displacement, we can take the absolute value of these, and our final answer will be 200.6 meters. And that is how you do the sliding down a ski slope on your back physics problem. I hope this was helpful.